All right, I think we're recording now. Okay. And then, again, I can send this to you guys after we're done. So this was what we went over just for the sake of being on our camera, right? We talked about place values, rounding up, right? Utilizing the number directly to the right. And now we're going to get into adding and subtracting of our decimals. So when we're adding and subtracting decimals, guys, it's pretty much the same as when we're doing whole numbers. But like I said before, try and keep everything lined up, particularly for adding and subtracting. You've got to keep the ones all lined up. You got to keep the hundredths. Woo, Carrie. You got to keep the tenths lined up, the decimals lined up, the ones, the tens, and so on and so forth. All right? Otherwise, it can make a mess, and you won't get the correct answers. All right, so adding this one up here. Okay, so there's nothing to add to the 2. I'm going to drop that down. 8 plus 4, right? 8, 9, 10, 11, 12. Drop the 2. And just like before, carry the 1. I'm going to ignore the decimal place, or I can even just drop it down right now. Everything stays in line. 9 plus 1 plus 2 is 12. Drop the 2, carry the 1 again. 6, 7, 8, and 9. Right? So there's our answer. That one's pretty easy, eh? Just adding those up. Subtraction, folks, is the exact same thing, right? Again, the decimal's just going to drop down, but you borrow just as we did before. Okay? When we get into multiplying is where things get a little trickier. We still treat it the same way as we did with whole numbers, right? Where if we do have multiple numbers, we have to put in those place savers. But these decimals are going to do some different things. All right? But let's continue here. Oops. Oh, someone I think is trying to come in. Hold on a second. I'm going to pause the video for a moment. Oh. Sorry, that took a screenshot. There we go. All right, so doing this question here. We're going to do, like normal, 4 times 3, right? 4 times 3 is 12. Drop the 2, right? Carry that 1. Now 1 times 4 is 4 plus that 1, right? So 5. So we're not done there, right? But we got the 52. Now we look at the decimal. There's only one decimal and only one number sitting behind the decimal. So we're going to look at our answer and make sure that there's only one number sitting behind the decimal. Clear as mud so far? All right. We'll come over to this one here. Now, we can ignore the decimals for the moment and just pretend we have 125 multiplied by 12. Right? So let's do this one. We're going to go 2 times 5. Right? We get 10. Drop the 0. Carry the 1. Remember, we're only working on the 2 right now. Now, 2 times 2 is 4. Plus the 1 is 5. Right? And again, still working on that 2 to get rid of this 1. 1 times 2 is 2. Okay, but that's not where we stop. Now we have to take care of the 1. Remember, we put in a placeholder, and again, I always put a little stick through my placeholder zeros just to remind myself. Now we're going after the 1. Right, this one here. So 1 times 5 is 5. 1 times 2 is 2. Remember, we ignore this ticky because that was on our first layer. It has nothing to do with us now, right? So 1 times 2 is 2. Then we go 1 times 1 and drop that 1 down. Notice how I'm keeping things lined up again, right? So, remember this becomes an addition. 0 plus 0 is 0. 5 plus 5 is 10. Drop the 0, carry the 1. 2 plus 2 is 4. Plus the 1 is 5. Sorry, it was an old Barney thing. 2 plus 2 is 4. And then just drop the 1 down. All right, so that's not our final answer just yet. If you come back up and look at these numbers, I have 2 decimals and a total of 1, 2, and 3 numbers sitting behind decimals. Do you guys see that? Right? 2 decimals, 1, 2, and 3 numbers sitting behind the decimals. So I have to come down here and again make sure 3 numbers are sitting behind my decimal. 1, 2, 3, and put it there. Okay? I'm going to quickly, just so you guys can see, right? We can type that into our calculators just to even double check. 1.25 times 1.2 should give us 1.5, right? So again, 1.25 times 1.2, 1.5. Okay? So that's multiplying with decimals. And again, if this number down here was like 1.2345, we'd have to do all the multiplying the normal way. And again, just however many numbers are sitting behind the decimal point, same thing has to be down there. Okay? So now coming into the division. Okay, again, going for it with the long division style. Right here, this decimal, when we have a whole number out front, that decimal's just going to sit up here, right? Just like if we had to carry it down in line with adding and subtracting. I'm just going to move it up. Now we can go through the motions here with this one, right? So for this one, we're going to go 7. 7 divided by 7. How many times does 7 go into 7? It goes in once. 1 times 7 is 7. Remember, these are subtractions, right? 7 minus 7 is 0. We bring down that 5. So now we say, does 7 go into 5? Well, no, it doesn't. So I'm going to drop a 0 up there. 7 times 0 is 0, right? The 5 is going to come down. Okay, I'm going to drop the 6. I'm just ignoring that decimal for a moment. Drop the 6 down to make this 56. 7 into 56 goes 8 times. 8 times 7 is 56. Okay, and we're end up with 0 at the end. Again, if you want, you can use your calculator and just double check that you got that one right. Right? Again, I do realize everybody's got calculators on their phones nowadays. You know, you can carry a calculator in your tool pouch and all that sort of stuff. But what if your phone went dead? Right? What if you couldn't access a calculator or your phone? Right? Being able to do this stuff, as I call analog, you know, without having electronics, is very useful. Now, don't kid yourself. I'm sitting here with a calculator off to the side to make things a little quicker here and there as well, and just to double check that I'm on track. Because just like I said on Tuesday, right, I make mistakes too, and that's why we watch out for each other for this. Now, this one here is going to be a little trickier. Because we've got a decimal out here and a decimal in here, this is a little too tricky to try and calculate like this. I mean, it's easy if you punch it in real quick in your calculator, but to do long division, it's going to be difficult. So, with something like this, I want to turn this number out here into a whole number. It's going to make it a lot easier. So I'm going to move that decimal over to the right until it becomes a whole number. But whatever I did to this number, I have to do the same thing. Sorry, Alexa, stop. Alexa, stop. I have so many damn notifications. Okay, again, however many times it moved over out here, it has to do the same in here. So I'm going to take the decimal and move it over one spot. So I'm going to rewrite that out now that we've modified it to 21 divided into 1,180. I had to think about that for a sec. 0.2. Okay. Probably should have moved that down a tiny bit, but we'll see how that goes. All right, so now I'm going to start using this one for using my equations. Okay, so 21 doesn't go into 1. It won't go into 11, but it'll go into 118. And I honestly had to use my calculator to make this faster. It goes into 118 5 times. 5 times 21 gave us 105. I realize it's slightly fuzzy there, guys. So 8 minus 5 leaves us with 3. 1 minus 0, 1. And 101 is 0. Okay? Then I got to bring down that 0 there. So 130. 21 goes into 130 6 times. So I'm going to put that up here. 6 times 21. And again, I just have my notes off to the side. If you guys are watching me turn my head. Is 126. And again, we subtract, right? We can't take 6 away from 0. So we are going to borrow from that 3. Cross it out, make it a 2. I know you guys can't see that very well there, but that's a 2 on top. Bring that 1 over to make it 10. 10 minus 6 is 4. And then 2 minus 2, 0 and 0. All right. Now, because just like our one before, because we've got a whole number, we're just going to put that decimal in line. I'm going to bring down that 2. 21 goes into 42 2 times. And we get our 42. Oops. Okay, so again, that was 130 right there. Okay. So, our answer to that, because I realize it's a little squishy, right? This ends up equaling, and these zeros are just placeholders, by the way, so we could write it as 56.2. Okay, and again, we could type that in. Right, 2.1, whoops, sorry, 118.02 divided by 2.1, we should end up with 56.2. Okay. How did that go? Did I lose anybody? Did anybody's minds just kind of explode? I have a couple more of that same one to show you because that one is a little tricky. Right? I didn't lose anybody on that side there. No, okay, we're good still. All right. I'm going to try a couple more of that division one. And again, it is recording. right? And I'll send you guys this link as your reminders. I know that sometimes when people are trying to show me something, it's easier for me to watch them do it first and then try it afterwards. And a few students said that they liked that part, that they could watch me do it and then at their own pace, they could watch the video and tackle it themselves. So if you're that type of person, let's try another one, right? So this one we're going to try. Actually, I'm going to write it down and I'm going to see if you guys want to give it a shot. I'll give you a few minutes. So 0.02 is going to be divided into 0.42. That's the question number 1. I'm going to put in another one. Excuse my left-handedness. Left-handed people are real special individuals. There we go. All right, so I've got those two there, and I'm going to put the recording on pause and give you guys a few minutes to try those. Okay, so we'll start the answering. So yeah. So the first one, the answer is 21, and we'll go through that together here. Okay, so again, remember, we want to change this into a whole number. So I got to move this over 2 times, which means I got to do the same thing over here, 2 times. So I'm going to rewrite that out just for clarity. Okay, so now our new equation is 2 divided into 42. All right, so going through there, how many times does 2 go into 4? Well, it goes in 2 times, right? 2 times 4. 2 times 2 is 4, right? Subtract that, we get 0. Then we bring down the next number, which is 2. How many times does 2 go into 2? 1 time, right? 1 times 2. And again, I'm just kind of going through every step just for clarification. Okay, so the final answer is 21. Did anybody get something different for number 1? All right. Does anybody want to tell me what they might have gotten for the final answer for number 2? I got someone typing. Okay, Tiana, you got 8. Close. Close. There's an 8 in the number. But what happened is I think you might have maybe either... there it is. Lanessa, there we go. So Lanessa has it. 0.8. So you were close, Tiana. So let's go through that. So again, I want to change this number into a whole. So I'm going over just 1 time. So meaning in here I go over just once. Right? And again, just for clarification. Yeah, okay, good. Just for clarification, I'm going to rewrite it. So now it's 12 into 9.6. Shoot, that's going to be... Sorry, let me give it a little bit more room. I just noticed that that's not going to have enough room to equate. So let me pull it down with another line on top. There we go. I got room. So 9.6. All right. So When we look at this, we go, does 12 go into 9? Nope. So put the 0 there. We're going to just pull the decimal up because that's where it's going to end up. But we look at this as a whole. Will 12 go into 96? Yes, it will. It'll go 8 times, right? And 8 times 12 is 96. Okay, again, 6, 0, 9, take away 9, 0. So there's our final answer. 0.8. Okay? So you see how you were close there, Tiana, right? You just didn't move the decimal to the appropriate spot. That's all. Okay. Did anybody get something different for number 2? All right. So I threw in 2 more multiplications. Again, just to have you playing around with these types here. So we'll run through it. All right. 3 times 5, 15. Drop the 5. Again, we're just going after that. Carry the 1. 7 times 3, 21. 22. That's right, right? Drop the 2. Carry the 2. Right? 2 times 3 is 6. 7, 8. And there we go. So we've gotten all those. I'm going to put a 0 as a placeholder. Now I'm working on this one. Well, this one's kind of a sneaky, cheeky little one because basically that whole row is 0, right? 0 times 5 is 0. 0 times 7 is 0. 0 times 2 is 0, right? You can't times anything by 0 and not get 0. So we'll head on to that next one there. But I'm putting a placeholder for the 3. I'm putting a placeholder for that 0. And now I'm working from this spot here. 1 times 5, 5. 1 times 7, 7. 1 times 2, 2. Again, keeping everything lined up, and I'm looking chicken scratchy right now. That's okay. Then we add them all up. 5, 2, 8 plus 5, 8, 9, 10, and 13. Carry the 1, 7, 8, and 2. But we're not done. Does anybody want to tell me where the decimal is going to go in this number? Between what 2 numbers? All right, I got someone coming in on the chat. Between the 2 and the 8, yes. Okay, because, and thank you, Vanessa. Right, again, there's 2 decimals. I got 1, 2, 3, 4 numbers sitting behind the decimal point. So I need 1, 2, 3, 4 numbers sitting behind my decimal point. Now I'm going to go a little farther and say round this to the nearest thousandth. Round this to the nearest thousandth. Okay, so remember, tenth, hundredth, thousandth. I'm going to look at this number. It's 2.84. Close, right? I wanted it to the nearest thousandth, right? So that's tenths, hundredths, thousandths. So I'm focusing on the 2, but it was a good stab. It was a good try. I'm focusing on the 2. And then looking immediately to the right. Remember, 5 or higher will change the number. So this then would become 2.833. Okay? Did everybody get that? Yes, yes, yes. Thank you, Dante. You got that. Yeah. Beautiful. Now, if I had said nearest hundredth, we would have focused on the 3, looked to the 2, and it would have stayed as 2.83. But for accuracy, I wanted the thousandths. But this is more accurate having all 4 numbers there. Cool. All right, I'll go through this one here. What time is it? 10 to 6. Time isn't going as fast as it did on Tuesday. All right, so this one here. 8 times 5 is 40. Drop the 0, carry the 4. Again, remember, we're going after the 5 first. 5 times 1 is 5, plus the 4 is 9. Then 5 times 2 is 10. All right. Then we're putting a placeholder, and now we're going after the 8. 8 times 8 is 64. I'm going to drop the 4, carry the 6, but this time I'm going to put it on top of the 4, right? I'm ignoring the 4 and using the 6. For 8 times 1 is 8 plus the 6, right? 8, 9, 10, and 14. Drop the 4, carry the 1. 2 times 8, 8 and 8 is 16, plus the 1 is 17. I'm not done. So I'm going to put a placeholder for the 5, placeholder for the 8, and now I'm starting here with that crazy 0. 0 to 8, 0 to 1, 0 to 2, right? You could skip that one if you wanted to, but I put it in there for clarification. Then we add those all up. 0, 9 and 4, 13. Carry the 1. 4 plus 1 is 5. 7 plus 1 is 8. And bring that 1 down. All right, go ahead and tell me what 2 numbers does the decimal go between? Where will the decimal go between? Kind of the same idea again.
The 1 and the 8?
Yes, sir. The 1 and the 8, right? Because there's the decimals. 1, 2, 3, 4. 1, 2, 3, 4. Between the 1 and the 8. All right. Now, just for shits and giggles, I want you to round it to the nearest tenth. The nearest tenth. The nearest tenth.
I just have a quick question.
Yeah.
When you're counting the decimals and you say there's 2 in the equation for each, so now you have 4 for the answer.
Yep.
Does it work when you add it up when the decimals get longer? Like if there's 3 and 3, it would be then 6 in the answer?
Yep. If I went and stuck even just an average, like a 0 behind there, or sorry, if I stuck like a 1 or something, yes, it should work out the same kind of way. I can even do one with a longer number if you'd like.
Yes, let's try one longer.
Absolutely. But yes, you guys are right when you said 1.9. Because I said round to the nearest tenth. So this is the 10th section. We look at this number here. It's 5 or higher. So yes, you guys got it. It would end up then being 1.9. All right, I'm going to find a longer multiplication one there for you. I want one that's something a little trickier. Oh, that one's boring. I don't know, let's throw something in. I think I can even, this one's going to be I think, boring, but let me try it. It's the one that's kind of the quickest and fastest in my book right now. Actually, all right, I'll keep it quick and simple. Let's try. You're going to hit me with these zeros, but I'm just trying to make it quick and simple. But you see how I got a lot of numbers going on here, eh, Bill? But let's try this together. This one I mishmashed a couple of questions that were in my book. So I haven't done this one yet myself. So with this one here, so if we run it through, we're going with this one first. 2 times 5, 10, right? Drop the 1, or sorry, drop the 0, carry the 1. 2 times 2, 4, plus the 1 is 5. 8 times 2, 8 and 8 is 16. Drop the 6, carry the 1. 4 times 2, 8, plus the 1 is 9. Okay? Now we're not done there. We're moving on to the next row. I place hold, and we're going after this one. I'm going to use the blue just so that we go over, you guys can see the different rows that we're going after. Okay, so now 1 times 5 is 5. 1 times 2, 2. 1 times 8, 8. 1 times 4, 4. Okay, now I got to put in another placeholders, right, to go after these ridiculous zeros. And I'm only doing them just to show the amount of numbers. All right. So there. But I place hold for that 1. And now I'm working on this layer here, which is 0, 0, 0, and 0. I might regret doing this one, but just for all those zeros. But again, place hold. Place hold, place hold, and now we work on that one again. 0 to the 5, 0 to the 2, 0 to the 8, 0 to the 4. Come down, one more 0. Place hold, place hold, place hold, place hold again, and then another 5 for the 2, for the 8, and for the 4. All right. I know that 0, 1 was a pain in the ass. Sorry about that. I didn't think that one through. I'm just looking for the amount of numbers. 10, carry the 1, 6, 7, 8, 9. 9, 17, carry that 1, 4 and 5, and then all these 0, 0, zeros. So up here we have 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Wait, did I do that? Hang on. 1, 2, 3, 4, 5. Shit, my bad. It should be there. So 0, 0.05790. Let me punch that ridiculous one into the calculator. 48.25. Now these zeros are going to come into the calculator as placeholders, or they won't show them at all. It's essentially what they are. 48.25 times 0.0012, and we get 0.0579. Like I said, 00, they're just placeholders. Okay? Did that make sense, Bill?
Yeah, that was awesome.
Yeah, okay, cool. I know the 0 was a bit of a pain in the ass, and I probably could have got a little more creative. But you did see that no matter what, we can put those. And I did try to make sure I didn't have zeros on this side of the numbers, because they would have, again, acted as placeholders in some cases. But you got to see that, right? That the amount of numbers that sit behind the decimals will get you into that proper space down there. Woo-wee. Yeah.
Question. Okay, so I'm looking at your equation.
Yep.
So you have the 5 over the 2 over the 1, and then you have the decimal over the 0. I thought places were supposed to, like, the numbers were supposed to have placeholders while the decimal is in between numbers.
I think and correct me if I'm wrong, I think you're thinking of adding and subtracting. Right? Because remember, and let me go back a page.
No, don't
Oh.
the page yet.
Yeah, okay, sorry, honey.
So you see where you have 48.25?
Yeah,
Okay, so you see where just below it you have a 0 under the 8, right?
yeah.
And then you have a 0, and then there's a decimal on top of that. Like I like.
Oh, you mean like...
I mean, it's offset. So I'm trying to remember, like, for every like tens, hundreds, so on. Is it supposed to have a proper placeholder, or can you write it just anyhow? Because I'm not really catching on that. Like, I kind of wrote it my way, and
Yep.
it's a little longer.
Okay.
But it's the same answer.
Okay. So the fact that these two decimals are offset, is that what you're saying is kind of messing you up?
Well, the decimal is over an actual number or a placeholder.
Okay.
Visually, I'm not lining it up properly. So when I did it my way,
Yeah.
I did it where it was 48.25. Okay, and then under the 48 I had 0. No.
Oh, okay.
Under the 4?
Yeah.
Yeah, under the 4 was 0.
Yeah.
And then I have my decimal between those two zeros.
So decimal there, then a 0 there.
No. It's 0.0.
Okay, here, let me write the 48.25 again. And then under the 4, what do you want me to put?
0.
Okay, under the 8, what would you like me to put?
Nothing.
Okay.
Right? What I have under the 8 is another 0.
Another 0 under the 8?
Yeah.
Okay.
Yeah, put another 0 on the 8. Now, between those zeros, I have a decimal.
Oh, right in here.
Yeah, I've been offsetting the decimals, but then
Oh.
under the 2
Yep.
would be a 0,
Okay.
and under the 5 is a 1,
And then you put the 2 out here.
and then I have the 2, so 48.250 would be a placeholder there. So it's a little longer, but it's pretty much the same answer. It's just that, like, when you did it there, like, I'm sorry, I'm pattern secret.
Yep.
So if I can't see the pattern, so how you had it written there, it didn't make sense to me. So I struggled to get through it a little more.
Yep. To me, what it looks like you've done there, Lanessa, is just you're cleaning it up. You made my kind of chicken scratchy look cleaner. And I like it. Yeah, you're just lining up some numbers. That's all. It just looks clean.
Okay.
But your numbers.
In my head, I was thinking it's two different equations going on where you can offset it and it would be fine. But
Oh.
I can't
I love it. I love it. And that's exactly what I see here is you are just trying to clean things up, right? So that things are in a line for your brain.
Yeah.
But it's the exact same numbers, just cleaner. But, right?
Okay.
Yeah, you did the same sort of thing and still the same idea remains. 1, 2, 3, 4, 5, 6 numbers behind the decimals.
Yes.
And that still makes sense that the saying how many numbers are sitting behind decimals?
Yes. The only thing is at the 9650,
Yeah.
the row on top of that is 0.
Oh,
No, hold on. No, sorry. If I...
The only way...
No, sorry. The row on top is not a 0. Sorry.
That's okay.
Yeah.
I mean, the only way that you would have a first row of zeros is if this...
Yeah, if the 2 was a 0 or there was a 0 behind the 2.
Yeah.
Right.
Yeah.
Yes.
Yep.
Sorry.
And then that would end up adding another layer to this whole silly business down here. But it's just another 0, essentially.
Okay.
Yeah. Cool. No, see, I like this, guys, because, and then, you know, this is the kind of thing, and I'm sure, Lanessa, there's someone else that probably is thinking the same way you are, right? That needs to see that cleaner, sort of more organized look and stuff like that, which there's nothing wrong with that at all.
Yeah.
Whatever helps your brain, you know, keep things organized. Like this little business right here with the zeros and the cross through. That's my way of keeping my brain in order.
Right.
Right? So little things like that. As long as we all got to the same destination.
Yeah. So because I have to keep things in order,
Mm-hmm.
I can't do short division.
Okay. Yep.
Yeah. If I can't see the process of how it's done the long way,
Mm-hmm.
I can't do short division or like you know how you can take away a row of zeros
Yep.
if there's nothing there. I have to put those zeros in or it just doesn't make sense to me.
Yep.
So
Oh.
you get the same answer.
Oh yeah, honestly, if I was still going through school right now and this question came on a thing, I would still be writing these zeros. Just for the sake of making sure I was on track. I second guess myself